Okay. So how long does it take a car that's traveling 35 meters per second to drive 35 kilometers? So we're trying to instill good habits because while some of you are having trouble here, these are kind of the intro level type problems. Once you start getting the hang of them, I think they'll be a lot quicker and faster for you. Some of you might already be quick and fast, and that's great. But they're going to get a lot trickier. Physics isn't like most classes. Most classes kind of do like a nice slow curve up in difficulty. You start off really easy, and then by mid-semester you're kind of part way up, and then it kind of gets a little harder as you go on, maybe even harder into second semester. Physics isn't like that. So physics starts out kind of simple for some people, not for everybody. But we start off kind of easy. We're at kind of, if I had to rank these problems on a difficulty of 0 or 1 to 10, I would say they're probably like a 3 or a 4. Doesn't mean it's going to be easy for everybody. I'm just saying overall. That number is going to go up to like an 8 in like 2 weeks. So we really want to get good habits on these problems so that when you get to trickier ones, and again, that doesn't mean they have to be easy now. I'm just saying when we get into ones that have lots of steps to them, you're in a better position to solve them. So the first thing we want to do is draw a simple diagram just to kind of show what's happening. That won't necessarily be a huge priority early on, but it will be going forward. So I like to draw a velocity vector, so an arrow for velocity, whichever direction that's going. And then I like to draw, and I always draw that in front of the object. And then I like to draw a displacement vector starting at the front of the object and going to wherever it's going to. Okay? So in this case, I would do my 35 kilometers that way. Now, how you do the pictures is up to you, as long as I can see a simple diagram. But here's the biggest thing you need to make sure you're doing, okay? And that is knowns and unknowns. So you need to figure out, what are you solving for, what are you given, and what do you need? So I need to figure out how long something takes. So we should probably take a minute to think about, what does how long mean? So I could say, how long is the table you're sitting at? And that would be a distance measurement. Or I could say, how long does it take you to get to school in the morning? That would be a time measurement. So I need to figure out, is this asking for distance or time? It says, how long does it take a car that's going this far or this fast to go this far? So that means, how long is time? So I'd write t equals question mark to make sure I have the time that I'm solving for. Then I need to figure out the rest of the thing. So it is traveling 35 meters per second to go 35 kilometers. That might not be obvious to you that this is a velocity, right? Because I could say I'm traveling 7 minutes, and that would be a time. I could say I'm traveling 4 miles, and that's a distance. I could say I'm traveling 35 miles an hour, and that's a speed. So it may not be obvious to you what it is. So if it's not obvious, how do you find it out? The unit. As soon as you see meters per second, you think, it has to be velocity. It cannot be anything else. It has to be velocity. Nothing else has units of meters per second. Only velocity does. Okay, speed, but we're not going to do speed very often. Okay? And then lastly, we got 35 kilometers, and it's okay, well, that's got to be how far I went then. Now, that can't be in kilometers. It's got to be in meters. If you want to show your work for that, if that helps you, do it. If you don't need to show your work because you know how to do it in your head, great. But for those of you who are still working through conversions, it would be 35 kilometers. For every 1 kilometer, there's 10 to the third meters, and that gives you 35,000 meters. So now that I've got my knowns and unknowns listed, what do I do next? What you do next is figure out the equation. So these are velocity problems. So I'm going to be using the velocity equation. So I'm going to write down v equals d over t. And this is the hardest and the easiest step. you need to plug in the numbers exactly where they go in the equation. So I look at the equation and I say V, 35, equals D, 35,000. Yeah, let's write the unit in here so we don't forget those. Divided by T. And you can write question mark here. You can write T. You can do whatever you want. I'm going to put it as a question mark. You can do it however works best for you. You can do smiley face if you want. Okay, it's all for smiley face. I don't care. Okay. Now I need to figure out how to solve this. So I got 35 meters per second equals 35,000 meters over question mark. So anytime you're trying to solve for something, you ask yourself, what's being done? Is it being added? Is it being subtracted? Is it being multiplied? Is it being divided? This is being divided. Whenever you figure it out, then you do the opposite to get what you need. So I'm going to multiply both sides by question mark. And the reason I'm doing that is because it is being divided, so the opposite is multiplied. Okay? I always multiply by the bottom, so the question marks cancel out over here, and I get a question mark on this side. So when I simplify that down, that gives me question mark times 35 meters per second equals 35,000. I'm trying to get the question mark by itself, so I need to divide both sides by 35 to get the to get question mark by itself. I'm running out of space here, so I'm going to move down here. So that gives me question mark equals, so 35,000 divided by 35 is 1,000. And as far as the unit goes, you get rid of the meters when you divide it out, but the seconds is still there, so it's seconds.